Alright, another video over integrals from the first worksheet that we had. This was the homework problem number 24. And it wanted us to integrate from 1 to 10 the function x over x squared minus 4 dx. And like if you go ahead and get started on it and all that, you try to do a u substitution, and you'd say probably u is equal to x squared minus 4 du over dx would be equal to 2x, and du would be equal to 2x dx, and dx would be equal to, let's see, what do we have there? 1 over 2x du. Then you'd probably go through and try to sub everything in that you had. So that would be, let's see, 1 going into u would be 1 squared minus 4, so that's going to be negative 3. And then 10 squared is going to be 100. Minus 4 is going to give us 96. And that is going to be x over u. Then 1 over 2x du, and those x's would cancel, so that would leave us with, we could go ahead and pull the 1/2 out, because that's a constant, negative 3 to 96 of 1 over u du. And that is the same thing as, see, I'll go to the next sheet. Okay, so there's what we had. And so that is the same thing as negative 3, 96, 1 over 2 of like u to the negative 1 du. And we've already said that, well, you should have picked up on that n, as far as our constant, cannot be equal to negative 1, because we start getting all crazy. But, so that would give you basically the ln of u. Ln of u, the du goes away, so it's going to be 1/2 ln of u from negative 3 to 96. But we're, you can't take the ln of a negative number, because that does not exist. And if you remember, our original integral was from 1 to 10, and we had on the for the denominator we had x squared minus 4 over x. Well, if you look at this x that's in the denominator, if that x is 2, we would have 4 minus 4, which would give us a 0 in the denominator, and that would give us a vertical asymptote at 2. So for all intensive purposes right now, since we're still just learning these things out, that does not exist. So, if you remembered, there was another problem like that a little while ago, that if you have a 0 or an asymptote that's in the denominator that is inside of, that falls within your interval, then you can just save yourself some time and say it does not exist. Or as far as like integrals go, since we're dealing with area, they call it does not converge. So anyway, there's that for that one, at least for now, since we're just now learning these things.